Hey there, welcome back. We're going to continue talking about rational functions and relations, and we're going to start graphing a couple of them. We're going to start by graphing the reciprocal function. It's like one of the easiest of all the rational functions, and it's most like the inverse function. Most like the inverse function. Okay. In that one of the simplest forms of a reciprocal function is equal to 1 over x. So that would look like y equals 1 over x. So that would mean that our constant of variation would have been 1. Okay. We also can have transformed graphs. So we could have f of x is equal to plus or minus a over x minus h plus k. That's going to move it around the graph. And so we're going to pick up key characteristics so that we can easily graph without having to do too much work. All right? Okay, so here's the general form. Y, or f of x, is equal to plus or minus. That means it could be a positive in front, it could be a negative in front. A over x minus h plus k. So if you think about the inverse variation, if k was something other than 1, like k was 2, we would have a reciprocal function. If k was, a half, we would have 1 over 2x. So those are all like, I'm trying to tie it in with what we did yesterday, okay? So let's just go over the transformations one more time. Okay, so if you have a negative in front, that's going to give you a reflection. Okay, it's a negative. That's going to be here. Your a value is going to either stretch or compress. The normal is 1. If a is bigger than 1, then it's going to stretch. If a is between 0 and 1, then it's going to compress. The horizontal shift works the same way. It's going to move left if this is a plus. Okay. Now what is a little bit new is that with a reciprocal function, the horizontal shift is going to move our vertical asymptote. All of these graphs are going to have both a vertical asymptote and a horizontal asymptote. And so the vertical asymptote is going to move left h units, or it's going to be x is equal to the negative of h. If we have, the whole thing's going to move right if we have x minus h underneath the in the denominator, and that means our vertical asymptote is going to move to the right. Okay. Now your vertical shift, that's just like before. It's going to move in the same direction as k. So if k is positive, it's moving up, and your horizontal asymptote is y equals k. If k is negative, it's going to move down, and your horizontal asymptote is going to be y equals negative k. All right, so not a lot of computation, but a lot of just understanding how graphs move, more critical thinking than computation. All right. So let's give a couple of these graphs a whirl. The first one I'm going to do is the parent function, or the parent curve. It's f of x equals 1 over x. So let's just start going through the key ideas. So let's identify a, h, and k. A is equal to 1. That's the numerator. H is what's being added or subtracted in the denominator from x, and it's 0. And k is what's being added or subtracted at the end, not in the denominator, and that's 0. The x-intercept is an important point. In order to find that, we have to plug in 0 for y and solve. So watch what happens here though. 0 equals 1 over x. So just intuitively, do you think that's ever going to be 0? No, and here's why. If I cross multiply, I get 0x is equal to 1, right? And if I try and divide by 0, then I get a domain error, right? So if I divide by 0, x cannot equal 1 over 0. You can't do that, right? Another way of thinking of that is I'm never going to be able to multiply 0 by a number and it equal 1, okay? So this is going to be does not exist, so we're going to use DNE, okay? The vertical asymptote, we learned from the previous screen that that's x equals the opposite of h, but 0 isn't signed, so that means x is equal to 0. My y-intercept, I always have to plug in a 0 for x. No matter what kind of function I have, that's just how you find a y-intercept. So we kind of get the same thought process as with the x-intercept. If I plug in 0 equals 1 over, oh, I'm sorry, no, y equals 1 over 0. I can't divide by 0, so this does not exist. Okay, so there is no y-intercept. I'm going to show you why in just a second. So the horizontal asymptote is always y equals k. So in this case, it's y equals 0. Now, I put a lot of points on here just so that you could get a good idea of what the graph looks like. But when we go to graph it on our daily assignment, if we can graph it with fewer points, amen. And actually, I'm going to show you how to use Desmos to get you a sketch of the graph here, okay? So let's, I'm going to switch my pen to red because I'm going to draw in my asymptotes, okay? They happen to be the axes, so that's why I'm going straight to the red here. Okay, so those are my vertical asymptote and my horizontal asymptote. So this is the line x equals 0, and this is the line y equals 0, okay? And I'm going to go back to purple for my points, and I'm going to plot my points here. Notice what I put in the center here. I put my vertical asymptote in the center because I want to pick points to the left and right because everything is symmetrical around that line, okay? So out at -3, I'm at -0.3. So that's like right here. I have to use little x's because remember my dots are funky. And at -2, I'm at -0.5. And at -1, I'm at -1. Watch how this is curving down. And then if I plug in a half, then a -0.5, I get -2. And the closer I get to plugging in like closer to 0, the closer it gets to the line x equals 0. So this is kind of like this, okay? It doesn't cross that red dotted line on either side, okay? And then I'm going to do the exact same thing with the positive points here. So at a half, I'm at 2. And at 1, I'm at 1. And at 2, I'm at a half. And at 3, I'm at a third. Whoops. And so here's my other branch. So with reciprocals and rationals, well, reciprocals, you always get two branches, okay? Two arms. I call this an arm and this an arm. So you notice that my graph is never touching the x-axis, nor is it ever touching the y-axis. That's why my x and y intercepts don't exist. It doesn't cross there, okay? My domain is, I have lots to choose from for my domain. It's practically in negative infinity to positive infinity. However, this asymptote right here, you have to exclude it, okay, because x will never equal 0. All right, so the way we write this, I'm going to let you write it in set notation because it can be grueling in interval notation. So we're going to write all x's such that x, and then we're going to eliminate what it can't be. X cannot equal 0. It can be anything else, but it can't be 0. Okay, and we're going to do that same thing with the range, all y's such that y cannot equal 0. Okay, y cannot equal 0. So that's because those are the asymptotes. So the domain is going to have everything except those asymptotes. X cannot equal 0, x cannot equal y. In terms of transformations for this one, this is the parent curve. This is the curve to which we compare everything to, so there are no transformations on this one. No transformations. Okay? All right, now we're going to graph 4 over x. F of x equals 4 over x. So I'm going to identify a, h, and k, and I get a is 4, h is 0 because there's nothing being added or subtracted down here. Okay, h is 0, and k is 0. Okay, my x-intercept, I plug in 0 for y, so I get 0 is equal to 4 over x. So that says 0x is equal to 4. Is that ever going to happen? Never going to happen. That's not going to happen. So this does not exist. The vertical asymptote is always x equals your h value. In this case, it's the opposite of h. I say that a lot, I know, but with 0, 0 doesn't have a positive or a negative. It's just 0, so this means that x equals 0 again. All right, my y-intercept, I have to plug in 0 for x and figure out my y. And again, what's going to happen is y equals 4 over 0. Can I divide through by 0? No, so this is another one that does not exist. My horizontal asymptote is always the line y equals k. In this case, my k is 0, so that means y equals 0. I'm going to go ahead and put those asymptotes in red. Okay, and then I'm going to plot those points. So at -4, I'm at -1. So here. And at -2, I'm at -2. And at -1, I'm at -4. And then watch what happens as I get closer to 0. At a -0.5, I'm at -8. Okay, and if I were to pick something closer, I would get even closer. I would go down even further. So here we go, like this. And notice that if you compare this to the one we did previously, this curve is further away from the origin, or from the intersection of those asymptotes, actually. And that's the effect of the stretch. It's stretching it. When it stretches it, it pulls it away from the intersection of the asymptotes. So this distance is larger. Okay. Now I'm going to graph the other side. So -5, no, -0.5. So here, and then 1, 4, and 2, 2, and 4, 1. And so here we go like this, okay? So I made my table. My domain is always going to exclude my vertical asymptote. So it's all x's such that x does not equal 0, or my asymptote. My range, same idea, all y's such that y does not equal 0. Okay. And then my transformations, this only one, this one is stretched. Okay, stretched. All right, last one. This one's got some more stuff happening with it. Okay, so it has a negative out in front, so we know for sure it's going to be reflected. So I'm just going to go ahead and put that down. Okay, my A is 1. My H, I always take the opposite of this number, is -2, and K is +1. My x-intercept, I have to plug in 0 for y, so I get 0 is equal to -1 over x plus 2 plus 1. So now I'm going to take this 1 and move it over. So I get -1 equals -1 over x plus 2. I'm going to multiply both sides by x plus 2. So I get -x minus 2 is equal to -1. negative x is equal to 1, x is equal to negative 1. So my x-intercept is negative 1, 0. My vertical asymptote is always x equals the opposite of h. That's why I write it as the opposite of h. So that's x equals negative 2. My y-intercept always has an x value of 0. So I get y equals negative 1 over 0 plus 2 plus a whole 1. So I get a negative half plus 1, so that's a half. So it's 0, 1 half. My horizontal asymptote is always y equals k. So this is y equals 0. Make a chart. Okay, so now I'm going to put my asymptotes in red. Let me put my axes in first here, sorry. Purple. So here's this one and this one. And then my asymptote is x equals negative 2. So here's my asymptote in red. And here's my horizontal asymptote. Boy, there's a mistake there. You guys are probably hating on me. That should be x equals or y equals 1. So here we go. Okay. Sorry about that. And then I'm going to plot these points. I'm going to do that in purple here. So at negative 5, I'm at 1.3. So I'm just a smidge above my horizontal asymptote. At negative 4, I'm at 1.5. At negative 3, I'm at positive 3. And then I'm at a vertical asymptote, so we're going to go like this. That's the left branch. And notice what happens. If you look at your other two, they weren't reflected, and the arms were in quadrant 1 and 3. Now that they're reflected, the arms are in 2 and 4, and that'll always be the case. So at negative 1, I'm at 0, so here, and at 0, I'm at a half, and at 1, I'm at 2/3, and at 2, I'm at 3/4. And then if I were to plug in like negative 1.5, I'd be like shooting down here like this, okay? So it's real important that you get a general feel for the two branches, how they move. Okay, so my domain is all x's such that x cannot equal my asymptote, which is negative 2. And then my range is all y's such that y cannot equal my horizontal asymptote, which is 1. And my transformations are reflected, left, 2, left, and up 1. All right, so here will be our assignment that we'll work on, and I will see you tomorrow. Thanks for listening.